In this video, I've chosen to make my regular foldable bicycle into electric bicycle, and I looked at different designs, but the one I want to use is one where I put a chain drive to make this wheel turn around. In the basic simple design, I'm going to take this motor with a chain. I'm going to make this sprocket spin. The first thing I wanted to do was make sure this sprocket fit in here. So let's move the camera around. You can see that there's a little hub that goes here, and the wheel fits in this hub. That was the first test. I'm going to take this adapter, put it here in the hub, and attach it to the sprocket so that when this sprocket turns, the wheel turns. So continuing on, you have this thing mounted here. I'm just tightening it up right now. Once it's tightened up, I'm going to go ahead and align these holes with these bolts right here, screw it in place. Finally, putting the bolts on here. I put two already. And then tightening it up. I also want to point out why I did the sprocket on this side. I know a lot of designs have it on this side, but what happens is if you're on this side, you're not engaged in the mechanism inside the hub, and so if you spin this chain to go forward, the pedals don't move. But if I were to put a chain on this side right here and turn the wheel, the pedals move. And so you could not have a pedal assist design. Instead, you'd be forced to remove the pedals, which is what a lot of people do. They remove these pedals and just make it a purely electric bike. But I wanted this one to be a pedal assist bike. So I want to make a platform for the motor and all the other pieces, the batteries and everything to go on. So I cut this piece of wood right here. It fits pretty nice in this section right here. And then I put the motor on here. Basically eyeballing where the sprocket of the motor and the wheel are, you can see that you probably should make a hole in the wood right about there where I have the cross pattern. So to finish this, to make this hole, we just take a drill here. We're going to drill a hole here to get it started, and then take this jigsaw and cut around the hole. So this is the hole right here. Now just a nail file to smooth out the edges. Since this is an adaptation, this is the original sprocket that came with the motor, but I want to use this 415 chain drive, and so I had to make an adapter to it. For the adapter, this is the piece that fits. And by putting this in here, I didn't have enough thread here for this to grip onto this shaft. So I had to use a hacksaw and a Dremel tool to shave off about a 1/4 inch thick or 1/8 inch thick piece that was on here. You can see the cut marks. Finally, I was able to put the assembled product right here. Now I want to show you something. There's going to be a little bit of a wobble. You can see that it's a tiny bit of a wobble, but we're looking at probably no more than 1 degree on either side, and the chain is not going to fall off because of that. Now that we've gotten this far, the next step is to attach this tablet to the bike frame. I'll be using this little plate right here that I got at Home Depot. It's strong enough to hold it. Now I'm not going to spend too much time on this segment, only because this is very specific to your bike, so you're going to do it differently. But by showing you how I'm going to do mine, maybe it'll inspire you to how to do yours. So as we saw before, there's a bar going this way across, which I'll lower this a little bit so you can see. Because the motor is going to go this way, it's going to interfere if I have a plate here. So I have to have it this way right here. I'm going to go ahead and mark. We established that the center line of the motor is going to be right here. So right here is where the other piece that goes underneath here, this rod that goes across, we're going to straddle that. These measurements are not critical because we can always adjust things. This is not that type of a science project. I'm going to go ahead and make marks right here. And I'm going to go ahead and drill 4 holes here. This number 8 bolt is sufficient to hold it. I just need to buy a longer one at Home Depot. I will then mark these holes right here and get threaded bolts also at the hardware store to mount the motor. That's all that this will do right here. Once we get that done, we'll go ahead and start attaching the chain. Okay, so this is looking more and more like the final product. We see right here the batteries, the motor, and we connected this. Yesterday I didn't want to go too much into my specific configuration because everybody's configuration is different, but I do want to point out some tips that I think you might be able to use. Take a look right here at how I connected these bolts from the plywood down here using these simple connecting plates. Now it's possible that this might still rotate back and forth, so you might want to put a screw here or on the other side just to ensure that it won't rotate. These batteries are going to sit right here. Now there might be some concern that these tops here of the bolts might run into the battery. You could easily put a piece of foam or even a piece of cardboard just to make sure that it sits on that instead. I want to point out the motor right here. For the motor holes, I actually made oval slots. And this lets the motor move back and forth when the time comes, in case you have to make some minor adjustments. Before putting the motor on, I want to just point out one other thing. This is the sprocket that originally came with the motor. It's the little tiny one inside here. But this is the sprocket that I need that matches the 415 sprocket that goes on the bike. So what I did was I took this welding, any kind of welding, to weld these together. So that now this actually fits on here. Another thing to point out is that this thread right here is a reverse thread. So it doesn't go righty-tighty, it actually goes left-wise. That's because the motor turns this way. Thus each time it tightens the thread on there. The problem is that if this goes this direction, it's actually going to make the bike go backwards. Right now it may seem differently because I'm doing a selfie mode, so everything's reversed. So I really need to make the motor move this way, which is going to have a tendency to have this thing slip out over time. Like this. You want to use some kind of Loctite. Don't get something too strong. This one is way, way too strong. You probably want to get a low strength one. So let's go ahead and put the motor back on. So continuing on with the presentation about the bike, I'm at the point now where I want to go ahead and connect everything to the controller or the computer. This right here is the actual one that I got. This is the YK31C. This controller right here is, like I said, the YK31C. And I'll explain how the different pieces of your motor, the battery, go together. Once I go outside, I can show you how the bike is put together. But for right now, here for the laboratory, we have a battery. And the battery is going to be a 24-volt battery. Positive goes here, the negative volt goes here. Also, going out to the motor, the positive of the motor will be attached to the blue and the negative to the yellow. In my particular case, because of the way the motor turns, I had to put it reverse so that the bike goes forward, and you'll see that when I get outside. Then there's the throttle. I got this throttle right here because I wanted the feel of a bicycle throttle, and these come like this. There's a harness that you go in here, but for the purpose of the demonstration, I just want to point out that you hook this up to what's called a derailleur. You can see that. And it's just very simple. The red goes to red, black goes to black, and this green goes to the blue. And when you hook those together, that's how you can throttle the bike. This right here the power lock. It says power lock. This is for where you have a little key that makes sure you can complete the connection. Now what I did here was I just simply closed the loop for this demonstration, but I do have a lock on the bicycle that I have outside I'm going to show you. One of the things that you can do is, if you have the battery hooked up and you have this thing connected, if you have a typical multimeter, when you turn the throttle and you have the wires connected to the positive and negative, you'll see that the multimeter registers 24 volts or 25 volts, and that's how I could tell that it was working. For a while it was not working, and it turned out that this was bad. And here's where I want to go into something about the company that I bought this from. I went on Amazon, and like I said, I did buy this particular model, but the people that I bought it from were fantastic. It was JC Moto. They asked me to send them pictures, they sent me videos on how to figure this stuff out, and I just felt like they deserve a lot of credit for what they did. So if I ever needed more parts or anything like that, I would definitely use those folks. So now that I've shown you this, let's go outside and I'll show you how it looks on the bike itself. Okay, so for those of you that have been following along, when I first started this project it was a lot warmer outside. Now we're getting into winter weather. So here we are, the bicycle's already built. I'm going to go ahead and focus down here at the bottom, and I'm going to ensure that the throttle, that the ignition key is on, which it is. I'm going to go ahead and turn the throttle. You're going to see that it moves. So now that I've done that, let's go ahead and take a look closely at how I put it together. So just like we explained inside the house, here's a controller, and the batteries are hooked up in series, and this is your positive and negative. I just chose red and white, and it goes to the positive and negative, red to red and black to white right here of the battery input. And then, as I said, inside the house, this the blue goes to the positive of the motor and the yellow to the negative. But in my particular case, because the motor goes clockwise, it's going to make the bicycle go backwards. So I had to switch these around for the motor. Doesn't matter, it's perfectly fine. And the derailleur, which is what gives us the throttle, just like I said, inside the house, you see that right here that red goes to red, black to black, and the green goes to the blue. And then that inside the house where I had the two with the cap, the little wire nut, that's your ignition. I just simply hardwire these cables together, and then this is my ignition. Okay, so next I'm going to go ahead and take it out for a ride to show you that it works, and then I'll bring it back and show you the modifications I'm going to make, which I may not be able to do until the spring because it is getting colder every day. Okay, so just to show that this works, I had some modifications to do on it, but I'm going to go ahead and show you. And this was designed as a pedal assist, so I don't expect to take off like a rocket. I have to pedal, and then this will help me out. You can see that I'm going fine, but when I pedal assist, it helps out quite a bit. Now you hear some noise right now. That's because the chain is banging. That's part of the design that I need to make sure I improve upon. But I go pretty well. I'm probably going about 10 miles an hour right now. And there's a car coming. I'll stop right here. Okay, so as you can see, there's always some kind of modification that needs to be done. So that noise that you heard, that's this chain. See that, how loose it is? I thought I had it tight enough, but it isn't. So I'll have to use the tool that I showed you in the earlier part of the video to take out another link and tighten it up. I thought that perhaps putting a wedge here, it might lift up the motor, but I might have tried to done that, but it just didn't work. Anyway, that's the modification I need there. Another thing is, if you notice right here, the cable for the throttle kind of hangs here. I'd like it to go along here. Well, fortunately, because this one was defective, I can go ahead and cut this and just attach these to this cable right here, to this throttle cable right here, and that will let me to nice and easily put it along the bicycle all along here. And then finally, just to make it look a little bit better, instead of having all this ugly duct tape, I want to go ahead and put something here to hold the battery in place, and even something to hold the controller in place. Once I do that, I want to cover this up. What I did was I bought this piece of plastic right here, and it fits over this. And so just lining it up right here, I was able to measure out right here where I want to go. Same thing right here, so that I can cut out a hole right here, and have a little bit of a lip showing. And with that lip, I can screw it in here so that it covers this up completely, and then the lid goes over here. So I'll have a sealed, sealed motor. I would show it to you, but like I said, it's getting colder, and Mother Nature's giving way to Jack Frost, so I may not be able to finish this in time. I only get to work this on the weekends every so often. But that's my design, and hopefully you enjoyed it. Maybe someday in the future I'll show another video of me riding along on a trail, and it'll be a nice, quiet, smooth ride. Thank you. Colder, and now it's getting warmer. Here we are in the spring. This is the finished bike product that I wanted to show you. So you can see I made the box that I have everything in here from the last time we spoke. And this box is sealed with silicone caulking. It contains space to put things in here. And here's the battery setup, the motor, and the controller. I've also added some other features. For example, this does have an on and off key. And I also connected a little battery meter, so that if I turn it on, it can give me the status of the battery. So, right there it says that the battery is full. So it lets me keep track of the fuel tank, so to speak. One of the things that I did was I changed out the motor. This motor right here was the original motor that was in here, but it wants to go too fast. It has about 3,000 RPM. And what that does is it has a tendency to overheat because the bike's not going to go that fast. This one has a gear reduction on it, so it goes slower, so the motor does not overheat. The only catch though is that the bicycle goes at most about 8 miles per hour. But that has to do mostly with the fact that this gear radius right here, if I were to increase the radius of that, it would go faster. So let's go ahead and I'll show you pretty much how it works. First I turn on the ignition right here. And then if we give it the gas, and there's no kick, it's very smooth. I thought I'd do it from this angle. I'm just going to lift this up so it doesn't kick, but... And it does have a lot of kick. I mean, this thing, it kicks up if... with all that power, it really does want to go. But this right here is nice, and I put this right here on top, and I could carry something on top of here. So my project is complete. I also bought this device right here. You can use to put the cell phone on here, and I have an app on my cell phone that lets me know how many miles per hour I'm doing. So, bicycle worked, project is complete. And you can always do more things. For example, the next thing I would consider doing is possibly just putting this motor on here with more of a voltage controller, so I can increase the speed up or down, as opposed to this using this type of controller. When it's a hobby, you keep doing more and more things. So there, project is complete. Hope you enjoyed it.